hashing, and if and this is hash function. Okay, so we have got few terms that got introduced. One is hash function, one is the hash table, one is the collision. Because if we find that my slot which I'm supposed to occupy is already occupied by somebody else, then there will be a collision, and then there should be some collision resolution techniques. So one is linear probing. You keep probing the element next to it like that in a modular fashion, and that is one option. The other option to but if this linear probing goes on for a sequence, what it means? Hello? Hello?
Yes, sir.
Yeah, if this linear probing goes on for a long sequence, then what it means, instead of getting something big of one, you are trying to, sometimes in the worst case, you basically have to probe the entire table. So this becomes again boils down to big O of n, or big O of n, or maybe big O of t, that is the table size. Is that fine?
Yes, sir.
Do you all accept? So it will not be big O of n, or maybe big O of t, you can say. So that is also not good, but there are few other options also. We go for double hashing and all this, and there are proofs to say that which one is better given what kind of distribution and all this. 40 weeks closed hashing. And then we discussed about the other option. Okay, so there are collision resolution techniques. We have got linear probing, quadratic probing, double hashing, and all this. And then the other option is, instead of because the previous option, it limits to store number of elements in the hash table. So if you have got t number of slots in the hash table, you cannot store more than t number of elements at a time, and that might be a serious say limitation in many cases, even though you actually store a very large table. Okay, and that too you cannot solve the collision problem completely. You make some compromises with the complexity that you would like to achieve. So the other option is, if we can store the elements not directly in the table, but in a separate chain or separate linked list, which is connected to that particular slot, or whose base address or whose starting address is stored in the table slot. So in this case, all the colliding say values with respect to the hash function, whatever is the hash function, all the colliding values are actually stored in a single chain corresponding to that table slot. So looking into the diagram, we can easily map it to a linked list. So a hash table now becomes array of linked lists, can be implemented as an array of linked lists, and each linked list can then hold as many number of elements as we want. Right? So there is no limitation. So what is the problem here? What is the problem here? Can we can we really completely avoid collision?
No, sir.
So here also collision is there, because collision means the hash function, whenever you give certain say values of x, say x1. So whenever you give some values of x, say it is x1, x2, x3. If I hash each of them, and if they all produce the same value of I say this x1, x2, x3 all collides. So these colliding values are so in this case also you have to search. So what kind of search you have to perform in the linked list?
Linear search. Sequential
Again, a linear
linear.
search. So, but the linear search is may not be as big as that of the searching the entire list of elements, right? But again, you do not know. It may happen that all the elements that you have that you try to insert at a particular point of time may have collided in the same table slot. Nobody knows. So in the worst case, it may again become big O of n. Okay, so what are the factors on which it depends that whether you will get an average case complexity of big O of 1? What are the factors we should keep in mind? Are you getting my question?
Yes, sir.
So in the previous case, so the only difference with respect to the closed hashing and open hashing is that where do we store the values? That's all. But the collision problem cannot be resolved because the collision is why the collision is occurring. It's occurring because of the some kind of biasness or maybe the hash function that we have chosen. So how to avoid collisions? You cannot guarantee that collisions will be avoided, but how to reduce the collisions?
Choosing a good hash function.
So good hash function, and for that, what do you need? What kind of information you need? You need to know a good. You need to have a good amount of knowledge of the type of inputs or type of values that you may have to insert, right? The distributions and all this. Is that fine? So without knowing anything, can you just say that what is the best hash function? That will randomly distribute the keys evenly in the table slots. It is not possible. Okay. So there lies the problem. So it depends on the problem. It depends on other factors. So in what sequence they're appearing and all this. So the fact is there are many things, and you probably need to know some need to have some domain knowledge from where the values are coming, so that you can ensure a fair or a something better search algorithm. May not be big of one, but at least something bounded within acceptable range. Okay, so noting this part, and in fact we can implement that closed hashing also with some collision resolution techniques, and we can verify, given an input sequence, random input sequence, which collision resolution technique is better, or in other words, which collision resolution technique actually achieves lesser number of collisions. So that will be better. So instead of going to that way, we just focus on this because we would like to have hashing implemented as a application of this linked list that we have just now implemented, the linked list class. Okay, so we stick to this open hashing. Open hashing is often known as open hashing. This is implemented using a chain of nodes. So this is also called as using chaining. Okay, so chain of nodes is a linked list. So once it is done, so we can implement it as if that hash table is having a linked list object or an array of or a collection of linked list objects, and a linked list object contains a collection of node objects like that. So now let us focus on the implementation details. So the class has a class hash table. What it should have initially. So that will be implemented as an array of linked lists. So initially, what you need to have?
Array of pointers.
A pointer to single linked
This
list.
much is enough. Why I define a pointer? I could have defined something like this also. SLL. I could have defined HT and then some value, say maybe 10. Okay. So class hash table, we can have something like this. So in this case, this is a static array, right? So if we implement it as if so if you know the number of table slots, if it is fixed and known, so you can implement a hash table as a static array of linked lists. But then it loses flexibility. So instead of doing this, we prefer to use SLL asterisk HT. Okay, so now we define a pointer, just a pointer to a linked list object. Okay, so this is what we define as a data member. Is that part clear?
Yes, sir.
And then during the construction, you are expected to, or you are supposed to provide the number of slots that should be in the table, and corresponding to each slot you should be maintaining a linked list. So in that case, you allocate dynamically, as we mentioned, the number of linked lists, number of linked list objects that should be there, which will be pointed, whose base address should be stored in HT. So say after construction, so this will be the, this will be the say the data member, and after the construction is over, you would expect this to be there. Okay, so after the construction, this will be there, and then as you keep on inserting, you will have these nodes one by one that gets added to each of the chain. So that's the case, and then you can have a HT size which will be holding the maximum size of the hash table. Okay, so what other methods do you think will be useful while implementing a hashing? Can you name some useful methods in that is required in the hash table class implementation?
Insert, delete, and search.
What is a basic function? Okay, to insert something, you should give the value to be inserted, right? So before you insert, what you should do? Given a value of x, what is the first task that you require?
Get the
Create
hash
a node.
Which
to
one?
calculate the hash value.
Yes. So there should be a, so one of the essential methods should be hash function, right? So hash function should accept what it should accept. It should accept the value of x, or the value that you would like to insert. What it should return? What it should return?
HX.
HX. So so the thing is, so maybe a hash function would accept some integer key. It may be integer key, it may be whatever key it is, and it should return some integer value, that is a table slot. Okay, so this is one important method that you cannot avoid. What can be the other one? So now we are talking about insert. So before you insert, what you should do now? So apply the hash function, and then once you get the table slot ID, you should be inserting that element there in that particular slot, or in the ith linked list object. Is that okay?
Yes, sir.
Where should you insert it? So the ith, say maybe in this ith linked list, you have to insert a node with the value x. So what should be the strategy? We may insert in a sorted manner. If I want, we can maintain the linked list in a sorted manner, but that hardly matters, because when we search, maybe it will ease up the search process. We can, instead of doing that, we can try to insert it always in the beginning. Okay, so inserting in the beginning, it is fine. So we just want all the nodes which collided to be there in the linked list. It doesn't matter where they occur. So maybe I would like to call hash insert, or insert hash, and that insert hash will call hash function, and then it will call because it is trying to insert some node with value x in a linked list, in the ith linked list, in that array of linked list. Is that fine? So I should be calling the some method of the linked list class. Insert begin. We had insert begin as a function, as a method. Is that okay?
Yes, sir.
Then there can be search hash. So you just say that I'm asking, I just want to know whether the value x, a node with value x, is there in the in that entire hash table. So for that, what I need to do, if I go for a search in a hash table, search for a value, I have to again hash it first, get the slot ID, and then go for a simple search in a linked list, in the ith linked list for that value x. Okay. So for that, again, in the linked list class, we have, say, for example, some insert function method. So I can just invoke that particular method. Fine. And then there can be display hash. Okay. So these may be the few methods. So because you would like to search whether the element x is there. You probably, if it is not found, you may be interested in inserting it, and you may be, and sometimes you may have to delete it also. So del hash means some value that you want to delete from the hash table. So for that, what you need to do, you have to go for a search. During the search, you have to go call the hash function, and you have found it in a suitable place. Then you call for delete operation in that particular linked list. So can you guess that implementing each of these methods will in turn actually call some of the methods that we have already written for the linked list class? Can you guess that?
Yes, sir.
So the amount of coding that you require to implement hashing is probably minimal. Apart from construction, we don't have to do a lot of things here. So I'll show you one implementation of this hashing, and I'll share the code also. So let us assume that our hash table, hash function is x mod 10. So x mod 10 means what it will produce. If you'd like to insert a value 29, then what will be the table slot?
9.
So it is the 9, right? And if you are having some values, say 105, what will be the table slot?
5.
5. So it's basically taking the unit digit, because I'm taking mod of 10. Earlier we just discussed the strategy that we discussed in our last class. It was x divided by integer division by 10. So again, so let us assume that in my implementation we'll go for this particular hash function. Okay, and then so how many table slots do you think is required if I go for this hash function? What can be the distinct number of values that can be generated by this hash function?
10.
It can be 10, because there can be 0 to 9 digits in the that appears in the last that appears in the unit place, right? So there will be no more than 10 digits. So when you construct the hash table object, you just say that I would like to have hash table with 10 linked lists, array of 10 linked lists. That's all. So it will be constructed as null list, and then it will be populated accordingly. Okay, and in fact, when you are using the hash table function, so these are basically the head nodes of those of each of those buckets or each of those linked lists. Is it okay? So let us see the actual interface. So now can you see the something in the top? What is this?
Header file.
Header file, my linked list. So so no longer you have to write, or you should not actually copy the entire linked list code here. Rather, you should uh, make a separate header file, which is mylinkedlist.h, and you should not have any main function there. And then if you just include that header file while you are writing this hash class, that will work nicely. Okay, so this is the class hashing. As you can see here, this is the only member of data. Now I have decided not to include even the hash table size, but you can always add it here if you wish to. And this is what is this? This is definitely by default is private. Now among the rest of the functions or rest of the methods, which one do you think? So do you have any choice? Something can you if you can make private?
Hash function.
So hash function, you see, if you are, so if I am the user of the hash table, so I am the consumer of the hash table, I really do not care about what kind of hash function you are using and what is done in the background, or I mean in the back end. Rather, I'll be interested to get a very fast search whenever I am trying to search or insert or whatever. That is what I'm interested in. I really don't want to know about how you are managing things internally. So this hash function anyway may be tagged as private. Okay. Because as a user, I may not be calling hash function directly. I do not need to, because hash functions will be called only when I would like to rather insert or search or display or whatever. I mean, insert, search and delete and all this. So a user of your, say if you have written this hash table class, as a user of the hash table class, I will be creating or constructing objects of the hash table, and then I'll be trying to perform different operations like this search, insert, delete, display and all this. Okay. But and these functions, some of these functions may be actually may be required to call this private method hash function. So because the policy is very simple, try to reveal as little as possible. If you are not forced to, don't reveal the details of your methods, data members and uh, member methods and member data. So that is the beauty of abstraction. So try to hide everything and anything that is possible, and you only make those members public which is essential to provide the user the access to this, to your class. So that is how you define your interface. Is that okay? And definitely the constructor and the destructors need to be, these need to be public. But then again, this HT size, so hash table size, I have made it public. And if I have used this hash table size while accessing the hash table and all this in the for loop, now somebody accidentally changes it because it is public, so it will be a complete disaster. So the better thing is if you make it a private member, that will be good, or you may reveal it, but don't use it in your for loops during searching insertion. Is that okay?
Yes, sir.
Again, so let us get into the code directly. So you can see this. Okay. Now here, if we are coming to the hash function, so can you see the hash function? So returning x mod ht size. So better I prefer to have this ht size because this is very this is vulnerable to get modified. So I would like to have it also as private. Let us make it private. Okay. So return x.ht hash size. So this is a simple hash function, and you can use different hash functions also if you want. Just to check it. Okay. What about this? What is this one? This method?
Constructor.
If I check it, what is this? Hash table constructor. A prompt will appear and then new SLL, because this n, it has got a default value 10, but if you want to make it 5 or maybe 20 or 30, whatever, it will be taking that value, and it will be actually creating an array of those number of linked list objects. Okay, is that fine?
Yes, sir.
And then it is assigning it to ht, which is a pointer to the hash table. So this gives us enough flexibility to create a table of desired size whenever we want to construct a hash table. We can dynamically create the array of linked lists. Otherwise, we could have done static also. So ht size will be assigned the value of n. What about this one? What is the purpose?
Deallocate the memory.
So can you tell me what will be the code inside?
Delete square bracket ht.
Will it be okay? Delete square bracket ht.
So we will be deallocating the values also stored.
Yes. So what do you think? If you just deallocate the, deallocate the entire table like with a square bracket ht, and if we do the, so what will be the difference there? Is there any difference? If I deallocate the entire table square bracket ht, will it deallocate the individual? Will it clean the garbage of the entire set of nodes to which each of them points, each of the object points?
Yes, sir.
Hmm?
Sir, the linked list destructor will handle that.
So I have done it explicitly. So this delete this also will work. So we can try and check both of these. Can you see this? What I've done here? So I've given a prompt htable destructor, and then what I have done individually, I'm trying to delete. Can you see ht.i.sll? So I'm trying to individually delete the single linear linked list, each of them. So the zeroth linked list, the first linked list and second linked list, like that, one by one they will be deallocated. So they are following the constructors. So this is one possibility. The other possibility is just write delete square bracket ht. Is that okay? Hello?
Yes, sir.
So let us stick to this and see, and then if we change it, then let us see that how the output changes, or if there is change, if it is allowed or not. Okay, so let us hide it first so that, okay. Now what is this? This is insert hash table. So insert hash table, what do we expect? It will be calling hash function, and then it will be trying to insert it in that particular ith object, ith hash table, ith linked list object. So this is what it means. Hash function, because it's a member method, so it can call other member methods even which are private. So it is calling hash function x, and this b is a table slot, and I'm trying to add this x by calling add beginning, a method of which class? Because htb is what? htb is the bth linked list object. Is that okay? htb is the bth linked list object. Fine.
Yes, sir.
And then I'm trying to add in the beginning an element with value x. So just by calling, so I'm basically, this is a linked list object, and that object is invoking the add beginning method to insert the value x. That is what it means. Okay, so then if I go for search, what is this? So search means you have to find out first which slot this x belongs, might belongs to, I mean it actually belongs to. So x hash function x is b, then I just write htb dot search x. So I invoke again. So this htb is a linked list, is a bth linked list object, which is a part of the hash table, and I trigger the search method corresponding to SLL class to search the value x in that particular chain. If I find, if it returns some non-zero value, non-null value, that means it has been found successfully. If it is not, I say that it is not found. So if t is not equal to null, I say that this is found in the hash table, and this is the information, or I can display the node information and whatever. Else I say it's not found. Is that fine?
Yes, sir.
And finally the display. So this is what it displays. So in displaying also, I'll just try to display. So displaying the hash table means displaying one by one the linked list objects in that collection. So HT0, HT1. So there also I'm invoking the display method corresponding to the SLL class. So now let's see that how it works. So any query till this point? So now what I have done here is hashing each one. So each one is a hashing hash table object or hash of hash table object. Then each one dot insert hash 15, insert hash 22, insert hash 72. So which of the linked lists should be having some values? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So which of the linked lists or the chains will have these values accommodated?
5 to
Fifth, in fact, the sixth one. So the index 5, the index 2, and in index 2 there will be 2. So there will be a collision here, right? Because 22 mod 10 is 2 and 72 mod 10 is also 2. So we'll find two elements or two nodes in the hash table in the linked list with index 2. Okay, then I display after insertion, then I delete 15. So probably this will be left blank. And then I display it once again just to see. Okay, so let us try this. Can you see this?
yes, sir.
So can you see can you read the constructor? So you have constructed the hash table using the hash table constructor, right? Hashing. And then within which to construct a hash table, what you need to construct in turn, because it is composed of SLL objects. How many SLL objects?
10.
10. That's a default one. And in fact, we have not specified anything here. So the default one will be 10. Okay. So there will be 10 such. So that's why 10 times it appears, constructing the null linked list each time. Okay. And then displaying the hash table. Why displaying the hash table? Because I have asked for this one. So after I insert, there is no comment here, then I display. So when it is displaying, it has already inserted 15, 22, and 72. So this is what the display is. So here you have got, and in fact, these actual entries in the table are actually the header nodes of the linked lists. Okay, so the table actually holds the header nodes corresponding to the linked list objects. So it counts the number of nodes also. It's 1, that is 15, and here is 2 nodes, 72 and 22. Is that fine? This part?
Yes, sir.
Then what we wanted, we just deleted something here. We deleted 15 and then again we displayed. So the deletion, there is no display, but then when I display it for the second time, I have already deleted one node. So that will appear here. So here it is. And now you see that the 15, this one, this got deleted. So it's successfully deleting. Okay. And then I call hash table destructor. Automatically will be called because the hash table object each one is getting deleted. So that is what it provides. So can you see the difference? So now if I try this one, can you tell me what will happen, if it will work or not? So up to this, is there any query? Any question till this point? Any other student? Any query? What do you think? Will it work?
Yes, sir.
Let's try. Can you see the difference now? So the same thing is done, but can you see the difference with respect to the previous one? It just displayed hash table destructor and nothing happened. And here what happened?
Destructors of
So
all
if I
linked lists.
get back to this linked list, which I have actually, so this is not this there because the header file should not have this main function. So I'm having this name main, but I have copied, I've created a header file by removing the header by commenting that main function. So that's a different file. But if I look into it, what is the okay, this is the SLL destructor and SLL destroyed. So these two appear. So this automatically invokes if I'm deleting that object. So that object, so it's an array of objects. If I try to delete it, it automatically invokes a destructor, and you immediately get a prompt. But in the previous case, it is not invoking the destructor, rather it is just deleting the that particular node. Are you sure that in both the cases the actual true nodes are deleted? Can you make sure that these nodes are not left as garbage while this deletion takes place in both ways? Is my question clear?
Yes. So
How to check it?
display it one more time.
Yeah, so just switch on the display and see how it what happens here. So we can right node destructor. So that will be invoked. Is that fine? So let us see. And what about the previous one? Why it is not? Can you tell me the answer? Why it is not showing here? I mean, why it is not? It is destroying, but it is not showing the prompt, the destructor prompt there. Why? See the destructor, SLL destructor. You are writing delete T. When you are writing delete T, so it is destroying, but it is not invoking the destructor. Same holds. The same case is here. When you are doing this, hello. So the prompt is not coming, but the nodes are getting destroyed in both the cases because we have executed this one. This delete T, but it's getting deallocated, but not by invoking the destructor. Okay, so let me again comment it out. Okay, I think, yeah, the problem is somewhere else. I should have done it in the header file itself to see the change. What is the header file? Header file. Okay, this is my linked list header file. Okay, what we have given here. So we have to uncomment this one. Try this. Can you see this now?
Yes, sir.
So here what we did finally in the hash table class, so it was in this way, and if I comment it and try this out, so those nodes are getting, so that node destructor is getting invoked. So let me see this. So this, so in any way they are getting destroyed in both the ways. Okay, so we are destroying the linked lists and we are destroying the nodes within the linked list, so everything is done. Is that fine?
Yes, sir.
Okay, any questions till this point? Do you have any questions? Hmm? Okay, so maybe I'll talk about this in the next class. So we have now discussed about a complete implementation of a class which involves pointer members, and it's an example of self-referential structures or self-referential classes. And we have found that how a class can be composed of some existing classes in a three-level hierarchy, and how the objects are getting created, destroyed in a kind of recursive fashion. You try to destroy the original object. So before it does so, it tries to destroy the objects to which it is composed of, and that in turn calls the objects to which it is composed of, like that. So in the construction also is taken place like this. But the nice thing that happens is you if you have designed some basic generalized classes, you can create new classes, or for some specific purpose, for new classes by just uh, using those methods. So things become very trivial, as you can see here. So that is the advantage of object-oriented design. It ensures say reusability to a very large extent. So that's why this becomes easy to maintain, easy to use and reuse, and you basically put very little coding effort. Okay, so this hash table class also should have I should have included one copy constructor, but I have not done that. You can always implement that part. So this is one thing. So I may take another maybe 5-7 minutes just to give the introduction to the next topic that I will be discussing about, and then I'll go to the details later on. Okay, so is that okay? Can I have another 5-7 minutes?
Yes, sir.
Sir, we have a class at 3, so try to conclude before that, please.
What is the time now?
Sorry, we have a class at 4, sir. 4.
So what is the time now? Is it
So 3:53.
okay? I think better we stop because it's almost 5-7 minutes left. Okay, just to make it a point, so just stop me after 5 minutes. So when I talk about say this is a class X, and this is a main. Within main you have got say A, B, then C. These are objects of that class, and we have got public or private, does not matter, some integer variables, say int x, then y. So what do you think that x, the size of A, B, and C, size of these objects? What will be the size of these objects? It's equal to the size of
2 integers.
2 integers, right? So this is option. So in other words, you can say that when and this ABC will be getting space from this stack segment, right? So A means this x and y. This is for A. This is for B, x and y. For C also there will be space for x and y, right? That is the case. Now it is like, so think yourself as if you are boarders in a hostel, and you are having your almirah, your cot, and your desk and all this, right? X, Y, Z. So maybe it is your say cot, okay, and it is your desk and your almirah. So every student, so this is a student class, and every student object A, B, and C, they will have their own property. See, once you get your hostel accommodation, you will be having that. But do you think that every student should have dining hall separately and maybe a common room exclusively for their own use? Do you expect that?
No, sir.
So even though the objects will have some of the members which are solely owned by them, they have their own space, they can store their own data. So x here it is 2, here the x may be 20, here the x may be 0, doesn't matter. But there may be some members which is a part of this class, but those members are such that each object or each student should not have their own unit of that particular member. Are you getting my point? What I'm hinting towards? So maybe like a table tennis board, TT board. So if TT board is there, okay, so of some class, say something. So if there's a TT board, say T. So this T, do you think that say this A, B, and C, all these 3 students will have their own TT boards also? Do you think that it is logical?
No, sir.
So, but still, so this TT board is a part of the students, I mean the access rights. So they will have that, right? Once you are a boarder of a hostel, so you should have access to the TT board, but you should have your own cot, terminal, and all this. So how to deal with this? So what kind of member? So it is a member, right? So it is a member of this class. It's a member of a student, of a boarder, but it is not having a separate existence corresponding to each boarder. So how to deal with it? Got the problem, I guess. Hello?
So static member.
So there comes the concept of static. So we'll talk about it more in details. So this is static. So static means, so these are the static members. Just to conclude this, the static members of a class is such that they will have one copy in the data segment, because anything static is in data segment, and rest of the whatever may be the number of objects that we have created, they will all share that single copy of that static member instead of having their own individual copy. Is that part fine?
Yes, sir.
So we'll see that how to access and what are the other issues and how to make it useful. What can be the, so I'll take one typical example where we'll show this use of static members. It is not just for something hypothetical. So we'll take one example in the next class. So in fact, we'll be talking about static member function, static member data. So in fact, a method can also be static. So we'll see what does it mean. And we'll talk about constant members, constant member methods, constant member objects. Constant member data, constant member methods, and constant objects. So we'll see all these kinds of variations in the next class. Anything else?
Sir, please share the code of the hash table.
Yeah, I'm doing now. Now only I'll do hash table and also the this linked list.
Yes.
All these I'll share. Anything else? Okay, then I'm leaving. Thank you.